This time we're going to talk about one application of matrix operations, which is cryptography. So there are many applications of matrix operations. Some are as follows. We have stochastic matrices, cryptography, Leontief input-output models wherein we analyze economic systems, and the least squares regression line for a set of data. In this presentation, cryptography will be discussed. So, because of the heavy use of the internet to conduct business, internet security is of the utmost importance. To protect the confidentiality and integrity of confidential information, the most popular forms of internet security use data encryption, the process of encoding information so that the only way to decode it, apart from a brute force exhaustion attack, is to use a key. Data encryption technology uses algorithms based on the materials presented in the lesson, but on a much more sophisticated level to prevent malicious parties from discovering the key. So what we're going to simulate is a simplified version of data encryption. So, cryptography is a message, or a cryptogram rather, is a message written according to a secret code because the Greek kryptos means hidden. Now, we are going to use matrix multiplication to encode and decode messages. To start with, we will assign a number to each letter in the alphabet. This is the English alphabet here, with 0 assigned to a blank space. So that's 0, then 1 to 26, 1A, 2B, until 26 to Z. So we have to take note of this, because this rather will be our guide when we encode and decode messages. So for example, we want to write the uncoded row matrices of size 1 by 3 for the message meet me Monday. Now, we say uncoded because we're just going to write this in two numbers with sizes 1 by 3. Now, how do we do that? So first, let's write that message. So let's write each letter like this. There's a space. Me, space. There you go. And then we write the corresponding numbers per letter of the alphabet. So this is actually 13. This is 5. 5. This is 20. Since there's a space, as you can see, this is 0, 13, 5, 0, 13, 15, 14, 4, 1, 25. Now, since we are required to have them in 1 by 3, I'm going to group them into 1 by 3 matrices. The last here, since there's no more number but I still need a 1 by 3 matrix, I'll just place 0. So now I have 1, 2, 3, 4, 5 uncoded row matrices for my message meet me Monday. Now this is what I would need to code. And for me to code, I would need a key. Now this specific key is actually another matrix. And it's up to the developer to decide what is that matrix that we will use as a key. Since we were required to have a 1 by 3 uncoded row matrices for the message, our key should be a 3 by 3 matrix, just like this one here. So we're going to use this invertible matrix. We have to make sure that the key is an invertible matrix so that we can encode the message meet me Monday. So let's copy all those uncoded messages. Wait a moment. Let's try to see if we can copy. Oops, wait a moment. There you go. Let's see if we can copy this to our next slide. Oops, there you go. Let's just bring it upward. Wait a moment. Select all of that, and let's bring it upward so that there you go, we have a guide. Okay, let's just fix that. Alright, there you go. So, how do we now encode these messages using this one? We shall now perform matrix multiplication. So, I will now have to multiply our first matrix here, 13, 5, 5, to, there you go, to our key, 1, negative 2, 2, negative 1, 1, 3, 1, negative 1, negative 4. In doing so, I will produce another 1 by 3 matrix, this time encoded so it does not directly correspond, or the numbers do not directly correspond to its letters. So if I'm going to do this multiplication here, I'm actually going to have 13, 20, negative 26, and 21. Let's just write that negative 26 better. Negative 26, 21. So 13 can still be placed here on M, but negative 26 cannot be because we don't use negatives in our alphabet. So this one will now be our encoded message. And we would have to repeat that process for every uncoded matrix that we would have. So showing it for the second one. So we will now have to have our second matrix 20, 0, 13 multiplied to our key. There you go. And actually this will give us a product of 33, negative 35, negative 53 rather. There you go. Negative 53 and negative 12. So as you can see, instead of directly accounting for or having that correspondence that we know 5 is letter E because you just need to count, it is changed already to a different number, which is more difficult to crack. So let's do the rest for the other uncoded row matrices. So there, to save time, we were already able to place all our uncoded, or instead of place, we were able to multiply all our uncoded row matrices to our key. And now, we can now, and now, we can now get all of these numbers, these coded row matrices, into one array, and that will be our message. For the encoded message, therefore, of our Meet Me Monday message, it will be the string of numbers 13, negative 26, 21, 33, negative 53, negative 12, 18, negative 23, negative 42, 5, negative 20, 56, negative 24, 23, 77. So all of these numbers here came from these numbers here. So this is telling us that this now is a message that you can send to anyone who has the authorized key and will be able to decode this message. That's an example of encoding our message using matrix operations.